Okay, welcome to 9.2, which is about the mean. This will be a pretty quick one. I'm not going to go through every single example, but I am going to give you a good gist of what the mean is, and then we'll work on it in class the next time we meet. So here we go. So first of all, and something that we should all know, is that a mean is a type of average. Okay, and when I say that, I mean that we're talking about something that's in between. It's our middle of the road. It's a type of average. So when you think of, the average height of somebody in a classroom that we kind of discussed before, it's a type of average. It's what's in between. We might have really tall kids and really short kids, but what is the most middle of the road? What's our average? And that's what our mean means. So our key idea of this section is about the mean, obviously. So the mean, as an actual vocabulary term, means the mean of the mean. The mean of a data set is the sum of the data divided by the number of data values. So in other words, it would look like this. The data they give you, so 8, 5, 6, and 9. Let's just pretend these are, these could be anything. Shots you made in a basketball game. It could be a whole bunch of different things. It could be, the inches of a snake or whatever. It could be a whole bunch of different values. But this is data collected. And then the mean would look like this. So you would add up all the numbers, 8 plus 5 plus 6 plus 9. And you should come up with 28. And then what you would do is you would divide it by the amount of numbers in the data values. So we've got 1, 2, 3, 4. So we would simply just take that and divide it by the 4 values that we had. Doesn't matter what they are, it's the amount that we have. So 28 divided by 4, our mean for this set of data would be 7. Because 28 divided by 4 is 7. So if you look at the numbers that you have, it kind of makes sense. If we were to order them first, 5, 6, 8, 9, what's right in the middle? It's missing, but it would be 7. So it kind of makes sense when you look at it that way. So example 1, finding the mean. I'm going to go a little bit away from what the book has and kind of give you my own type of example. So we're having a ski jump competition in our classroom. And the people involved, let's see here. We've got Jake. Jake's one of our people. Okay. And we've got Gavin. Let's see here. Audra is doing the ski jump. And let's see here. We're going to have Katie in there. Katie's going to do the ski jump. And we're going to have Taylor. Either one of them. I'm going to erase that real quick. Either one of them. Let's see here. Cage is jumping. Let's see. Breslin's jumping. And one more. Max. Okay. So those are our ski jumpers. They're going to be in this ski jump competition. And the highest jumper, so we're talking in feet here, okay? So the person that can jump the highest would win the competition. But we want to see what the average height that these kids are jumping. So with the data that I'm going to give you, I want you to try to find out what the mean would be. Okay, so the ski jump competition was for the big air, we'll say X Games, you're in Aspen, it's cool. And these are what the high jump, what you got in the competition. So Jake, you got 20 feet, Gavin, 22 feet, Audra, 21 feet, Katie, 18 feet, Taylor, 23 feet, Cage, 24 feet, Breslin, 23 feet, and Max, you kind of, I don't know, maybe you hit a bump or something, but you only got 16 feet. It's cool. So what you're going to do is, I want to know what is the average that we get. Obviously, we know that Cage, he hit 24 feet. That's the best he could do. Okay, he got 24 feet. But what was the average of all our competitors in this situation? So all I'm going to do is I'm going to add 20 plus 22 plus 21 plus 18. And as you go, if you want to check them off like this to make sure that you're doing it correctly, you may. Or you can do some mental math as you go, but I'm just going to do it this way. So then I get 23 24, 23, and 16. I'm going to add them all up. Again, this is where mistakes are going to occur the most, but once you add them all up, you're going to get your answer of 167. So now that I've got my answer, my next step was take whatever answer you got. So I got 167 total feet if we were to add everybody up, and then you count how many people you have. So I've got 1, 2, 3, 4, 5, 6, 7, 8 people. I'm going to divide that by 8. Because I'm kind of doing this one on a whim, there will be a decimal, and that's okay. So now I take 167 divided by 8. 8 goes into 16 2 times. 8 times 2 is 16. Bring down my 7. How many times does 8 go into 7? 0 times. So 0, we bring down our 7. Now this is where a decimal comes in, because we don't have a place for it. And that's where we add in a 0. How many times does 8 go into 70? 8 times. 64. Do my subtraction, I should come up with 6. Put in another 0. Bring it down. 0. How many times does 8 go into 60? 7 times. I'm running out of room here. 54. Or 56, sorry. 56, I got a 4. Bring down my last 0. Now I have a 40. 8 times what equals 40? And equals 5. So, my answer here becomes, what is my average ski jump height? And if I have a number, especially like this, where I'm going to come up with a decimal, I'm going to want to round it, okay? Round it up to the nearest foot. And in this situation, I can look at my 8 and look over here. My 8 will now make my 0 a 1. So my answer to a question like this would be 21 feet. That's my mean. That's my average. And that's exactly how you figure it out. You take all your data, you add it up, then you divide it by the number of people in this situation, or the number of data pieces that you have. Once you do that, then you've got your mean. And that's really all there is to this section. Alright, our last piece of information is our outlier. Okay, there are outliers in situations that can really mess with your mean. And that's why this guy that I drew is like, what? What do you mean, mess with my mean? So let me give you the definition of an outlier and then give you an example of what finding the mean with and without an outlier. So it's a really simple concept. So an outlier is a data value that is much greater or much less than the other values. When it's included in a data set, it can affect the mean. So we're going to go back to our previous example with our skiers, okay? So we're going to use all our skiers, and then we're going to add in one more person, okay? And that person's not going to do so swell. So here we go. And that last person is Dayton. Dayton really takes a fall, but he's still got to be recorded because he's part of this plan. So he gets 2 feet. Poor Dayton. Alright, so 2 feet, I put him in red because he's our outlier. And what that means is I'm going to put this on a number line. And you're going to kind of see what that kind of looks like. So our number line is going to be like this. Okay, so normally you would look at this information, and I would normally have all the numbers completely done on this, but because it's from 16 to 2, it's a big difference. What you're going to do is you would do a dot plot, and you would put in all the different numbers that you have, so it should look like this. Okay, so I've got my data displayed on a dot plot, and what I'm noticing is, okay, so I've got a little bit of a cluster going on here. Obviously, this is my peak. I've got a gap here, I've got a gap here, and I've got obviously a major gap here. So what you're noticing is you're analyzing your data, right? You're interpreting what it means. I'm looking at this. If I were to add up all of these numbers, so we already know that that was the 167 for all those, and I add 2 more to it. And if I were to divide that now by 9, because there's 9 people involved, my data would change to, I would round it, it would be a decimal, but I would round it to 19 feet. If you think about it before, my average was 21 feet. So you're talking a difference of 2 feet. And you might not think that that's a big deal, but when you're out, or when you have a number that's out, out there so much, 2 feet, It's a huge difference. It drops your average a lot. If we were to say, okay, in this ski jumping situation, you know, a really good score is in order to get a good score, you have to at least jump 20 feet. Well, if our average or mean now becomes 19, that's not very good. And it's not very good anymore because our outlier was 2 feet. The big difference here is you're going to do it with and without the outlier. So this would be with the outlier. The without would end up being the 21 feet. But don't forget, you would have to take Dayton completely out of the picture. So he's not even part of our ski jump competition anymore because you have to take him completely out. So an outlier, that's what an outlier is. It's when you have something that, you know, in this situation, Dayton fell, so he only got his 2 feet or whatever, and he got injured, or I don't know, something happened. So whatever that situation was, he becomes an outlier. So they take him out of the mix for figuring out what the mean would be in this situation. So we would stick with without the outlier would be 21 feet, and with would be 19 feet. You only have 2 practice problems. You need to find the mean. So don't forget, add them all up, divide them by the amount of data sets you have, and you would round up in this situation. So we're doing ages in a class and then movies seen this week. Hope you have a great weekend. See you on Monday.